My name is Beatriz Vinal Murciano. I'm a software engineer at Microsoft, working on the SwiftKey keyboard at the moment. I've been with the SwiftKey team for 12 years, and I spent about 10 of those working on Android. So if you've just been remembering all the versions in the keynote, that was around the gingerbread times, which has been a while. I've flown in from Spain to be here, so those comments about getting to see different places to do a talk also resonate quite a lot. And today I'm going to talk about how we use AI models in our app, which you can see here. After a brief introduction about who we are and why this topic is important to us, I'll talk about the main options we have when we're dealing with AI models, basically having them on the cloud or on device, and then I'll go into details of the different options we have when the models are on device, leaving some time at the end for questions. So as said, I work at Microsoft. Microsoft is one of the big publishers in Android. It has over 3,000 engineers working in Android at the moment, and over 100 apps published in the Play Store right now. And I work in the new Microsoft AI team, which is focused on consumer AI products and research. It builds the trendy products of the moment, like Copilot and Designer, but it also has other apps like Bing, Edge, links to Windows, or our app, the Microsoft SwiftKey AI keyboard. And this is what we're going to focus on today, so let me tell you a bit more about it. The Microsoft SwiftKey AI keyboard, which I will call SwiftKey from now on, is, as the name says, a keyboard. It lets you type. It lets you type by tapping on the letters one by one, or by moving your finger over the letters like you saw in the video. It lets you do that in over 700 languages, and in up to 5 languages at a time. It also has a lot of other features for all of your input needs, like emoji, GIFs, clipboard, and it now integrates the latest generative AI tools like Copilot and Designer. It is available for free for Android and iOS. Since you're here, I guess you're most interested in the Android version, and that's the one I work on. So you can get it for free in Google Play, and you can see that it's been downloaded more than 1 billion times. The people who work directly on the app is a team of 10 engineers working on Android, although there's, as you can imagine, a bigger team around us. And they're mostly based in London or around London in the UK, where I used to live as well, although I recently relocated to Spain, my hometown. And people are asking, where's that accent from? I was born in Spain and spent 10 years in the UK, and I speak like that now. So as we work on the keyboard and evolve the product, something we really care about is the app size, which is currently around 20 megabytes download size and 55 megabytes right after installation. And this matters not only because everyone likes small apps and respecting the user's storage is a good thing to do and is the respectful thing to do, but also because if your app is very big, then users are more likely to uninstall it. And working with device manufacturers becomes more difficult. However, something we've noticed as well is that more and more of the new things we have to do include some sort of AI, and this usually comes with some big model that we have to manage. And there's a challenge in keeping the app small while adding all of these new capabilities. When I talk about an AI feature, is nothing mysterious. For us as Android developers, we don't usually work on the AI. It's something that someone gives to us, like a bunch of files, and we just send an input to them, it does something with that, and we receive an output. We don't usually look at what's in there. It's a black box for us. In the slides, I've represented that with a green box called AI feature that will typically contain one or more AI models that will power the feature, some engine that those models run on, and some additional data files for configuring the models. These can get quite big, and that's usually due to the models. That's the part that gets bigger. The engine and the configuration files are usually smaller. We don't need to worry that much about them. But I've said that it can get quite big, and big models is also in the title of the talk. And a good question is, so how big is big when we're talking about big models? And the answer, like to many, many things, is it depends. Is whatever makes your app size significantly bigger is something that you're just not going to want to throw in there mindlessly. You want to think about it carefully, think about where you're going to place it. And it doesn't matter what that limit is for you, the techniques you're going to have to use to deal with that will probably be pretty similar. We've been in this situation a few times now, and we've analyzed our options a few times. And it usually comes down to a few trade-offs. And that is what we wanted to share today. So if you are in a similar situation, you can make more informed decisions. Just to check, does this sound like a situation familiar to you or something you might have to do in the near future? Can you put your hand up if that's the case? Okay, yeah, we know what we're talking about. Right, so first, let's look at what happens when we have the model on the cloud or on device, which are the main different approaches. There is no good or bad option, and I will repeat this many times. There are only options more or less suitable for different situations, so it's good to understand the implications, understand what's going to happen if we go for one option or the other, and see what's more suitable for us. When the model is in the cloud, all of the complexity is in the cloud somewhere. All of this AI is somewhere else, and maybe we deal with that as well, but if we're just working on the app, we don't need to worry about it. From the app side, it is very simple. We make a request, and we receive a response. And it's just a network request with some data that goes up, and some of the data that comes down. That is usually straightforward for us. The good thing about having it in the cloud, apart from having a simple app that is therefore smaller as well, and its size doesn't increase, is that there's more storage and more computer power in the cloud that you can have on the phone. So you can do more things and more quickly. You can also update the model anytime. You just change it in the cloud, and then any new requests that happen from that point onwards hit the new model and get the new results. It will be updated for all of the versions of the app that use that endpoint at the same time, very quickly. Then what's not so great is that you need to think about privacy, and that can get a little tricky. It doesn't necessarily have to, but because there's some data leaving the device, you're going to have to start thinking about what is the data that you are sending. Is there any personal information in there? Is anything going to be stored in the server? Who's going to have access to that? How long is it going to store for? If someone requests you to delete their data, how are you going to honor that request? What happens in all of those cases? So maybe there's an easy answer, like you never store anything and everything is fine, but you need to give it some thought. The problems with this approach is that there is a cost every time you make a request. If you make a lot of requests, the bill will go up, and eventually someone will have to pay it. You may be able to afford it or not. That's something to consider. Just bear in mind there will be a cost, and calculate how much it's going to cost you. And the other caveat that might be obvious, but if your app is on your phone and this AI is in the cloud, you need an internet connection, and the service needs to be up. If one of those things doesn't happen, your feature is just not going to work at all. So putting this all together, when is this useful? Well, sometimes we have no choice. Some models just won't fit on a device or won't run in a reasonable amount of time in a device. And in that case, you need to have it in the cloud. And this is very quickly evolving. What you can do on device changes all the time. So just check when you need to do it, what's available, and whether that's possible or not. But other than that, if you do have a choice, this is good when features don't use very often, so the cost stays manageable, and when latency is acceptable, because there will always be some extra time to make the network request and to receive the response. So it won't be immediate. It will be quick, but not as immediate as when it's on device. And let me show you an example of these. How we use these in the keyboard. Basically, every feature that uses generative AI at the moment is on the cloud. The more powerful features don't exist on device yet. So this is an example for the sticker generation feature, which creates all of the stickers you can see there and many more. And how it works is you go to sticker panel in the keyboard. You can enter any prompt. There I entered Android dancing. You wait a little bit with a spinner, and you get some stickers that then you can send to people or save for later or do whatever you want with them. The feature uses DALL-E under the hood, DALL-E 3 under the hood, which can't run on a device. It has to be on the cloud. It's not used very frequently, believe it or not. Most people just want a keyboard to type. They type all the time, and they generate a sticker every now and then. So the usage is OK. The cost is acceptable. And latency is not a problem here. It's not just the latency of the network request. The feature takes a little bit to run. And we've learned over time that when you do a search or when you generate anything, it takes a bit. We see a spinner. We understand it. As long as it keeps moving, it's fine. We know what's going on. A few more examples here are other generative AI features. We have Designer, which is very similar to sticker generation, but it can generate any type of image, not just stickers. For example, I asked it to do a droidcon San Francisco talk, and it did that. And we have another feature, for example, for tone change, which rewrites whatever sentence you give it into different tones, like professional, funny, for social media. There's a bunch of them. For example, I said droidcon San Francisco is great, and asked it to rewrite it in a professional tone, and I find droidcon San Francisco to be an excellent event. Very professional. Now, let's look at what happens when the model is on device. And as the name says, it is on the device. It can be queried locally, but it is also taking space on the device because it's there. And what were advantages of the models in the cloud are the disadvantages of this approach and vice versa. So the problems before, we don't have them. There's no cost for querying the API, and the model is available all the time. It's part of the app. You can use it anytime. It's free. Privacy is, again, not necessarily easier. It's probably easier because the data doesn't leave the device, but you can do pretty horrible things with data on device, so you still have to think through it. It's just maybe an easier thought process. And we may have more problems to update the model, because if it's part of the app, maybe we have to update the app to update the model. It depends on implementation, and I'll go into details later. The problems we have are the problems we didn't have before. So limited size and computing power. What you can do with this that fits in your pocket is never going to be as much as what you can do in a massive data center. Phones get better all the time, but they're still limited. And then the size of the app is going to increase in different ways, as we will see when I talk about implementations, but there's a model that it will generally be bigger. So this is a good approach when we have smaller or faster models that don't increase the app that much and that can run very quickly on device, that are used frequently, because if we put something with frequent usage in the cloud, it will be expensive. And when performance is important, because we don't have this extra latency of going to the cloud and coming back with some data. And I have more examples about this when I talk about the different implementations. For now, just think about typing, for example. When you're typing, you need a really quick response. It's something that is happening multiple times per second. Probably, if you type quickly, you want a lot of responsiveness on every key press, and you want the model to be always available. You don't want to go into a tunnel or into the tube and then suddenly be unable to type. That would be a really bad experience. And I want to clarify something about latency, because it may look like I said that on device is always quicker than in the cloud, but no. What happens is that when it's in the cloud, we have to make a network request and we have to receive a response. And this always takes some extra time that I've represented in purple there. But we also have to process some data, and the data processing time is in green on the slide. That can happen more quickly on the cloud. So it depends, because maybe the the connection time may be offset by how much more quickly you can do things on the cloud. So if you have a very small operation that is really, really fast, it will be generally quicker on device because you don't have the connection overhead. But if it's a really complex and really long operation, it might be quicker to do the network request and have it running on the cloud. It depends on your circumstances. It depends on what you're doing, what's available for you in the cloud, how quick it is on a device. So just check what you're doing, measure and understand what's going on, and make the right decision again, or make a decision in a more informed way. So putting this together, when you have to choose between on-device or in the cloud, first of all, check if you really have an option, because maybe the model doesn't run on device and then it has to be in the cloud and you have to pay for it. If you do have a choice, consider other aspects. Usually the most important ones are how much is it going to cost in the cloud? Can you pay for it? Does it need to be always available even when you don't have any connectivity? Can you make the app a bit bigger? How big does it have to be? Is it going to be important? And then maybe consider privacy and model updates. For us, we've seen that those are not usually the things that make us change the decision, but they are important. They may be more important in other cases. So, as I was saying, using the cloud endpoint is straightforward for the app developers because it's just a network request, and the complexity is outside the app. But when the model is on device, the complexity is in the app, and we have to deal with it ourselves. So let's see what we can do. First of all, the model is our model is somewhere on the device. It is taking up storage space somewhere on the device. But we can start thinking about, does everybody need it? And does everybody need the same model? And what happens to people who don't really use this feature? Do they need the extra storage as well? And we can come up with different alternatives and analyze them like we did before. Latency and privacy will probably be the same for all options because they're similar approaches, but we need to think about the download cost, availability, the app size, and how is the model going to get updated. So we'll look at options about what to do when we have to integrate our model in our app. But before, hang on a minute, because maybe you don't need any of these. So now you can have Gemini Nano running on device, on some devices, and if you can use that, that's great, because first of all, you don't have to build a model. Maybe you don't do it, but your colleagues don't have to build a model. The app size increase will be minimal. You just have to include some SDK, and I think you can just use it. I haven't used it yet, but I believe that's how it works. And there's a talk about this at 425 that I encourage you to attend. If you want to know more about this, I will attend and learn about this aspect of AI models as well. The problems of this is that it's not your model, it's Google's. So the model is what Google wants. It's updated when Google wants, and it's available where Google wants. Now it's just the Google Pixel 8 Pro and Samsung S24 series. But I would expect that to expand quickly. I obviously don't know, but keep an eye on it. So as I said, we don't use this, but if you don't need any customization, I think this will be a great option, and you save a lot of travel and a lot of work. When things get more interesting is when you do have a model, your own model or your colleague's model, and you have to integrate that, you have to do something with it. And what do you do? The easiest option is to just make it part of the main app. Put it in the app somewhere. It will usually be the assets folder or the raw folder in the resources, and it just becomes part of the app. It is always there because it's part of the app that you put in the Play Store. In the Play Store or any app store, the app store owner will pay for the download cost of downloading all of these extra bytes in the model. which is always nice. However, your app will be bigger, so users may not want to install it that much, or they may uninstall it more quickly. Also, you always have this model there, so if some users are not going to use this feature, you're still going to be using their storage, and they may not like it, they may not understand why the app is so big if it doesn't do what they want. And the model update is linked to the app update. You can't update the model separately. You have to update the app to update the model. There's always a tie between the app version and the model version, and you will always have old model versions running on old app versions somewhere. So this is useful if you have features that are beneficial for all users, that all of them are going to use, and if they all use the same model. And at the moment in the keyboard, we don't have any features like that, because due to the nature of the keyboard, a lot of things are based on language, and vary a lot per language. So there's nothing at the moment that absolutely everyone needs and everyone wants to use. However, this is a great approach for prototyping because it's very quick. You stick a file in there, compile, and that's it. So we used it for prototyping, not in production at the moment. So one of the problems we have here is that we are taking up storage space even if we don't need to. And the other one is that we need to distribute different things to different users. And we've done a couple of alternatives, one to deal with each of the problems. So if we have a model that only some users will use, but all of them will use the same model, we can put it in a dynamic feature or asset pack. That would go for a whole talk, but in short, these are optional modules. The app can work with or without them, and you put them in the bundle that then you upload to the App Store, and they get downloaded with the app whenever they need it. You can install them when the app is installed, or you can install them when certain conditions are met, like when the API is higher than something, or you can install them on demand, which is the approach we use, which is from anywhere in the code. Whenever the user does something, we download it and install it. The important thing to note here is that not all of the app stores support this. It is a Google Play thing. So if you are using Google Play only, great, you can use this approach. But for example, if you have to distribute your app in the Huawei App Store, this is not supported, so this is not really an option. Because the model is still part of the app, the advantages are similar to before. The App Store is going to pay for the download costs of downloading all of these extra bytes. But now the download size is not going to increase. It's going to stay the same, and we'll only install the extra features with the extra space if users are going to use it. The problems are that you need to handle all of this installation of dynamic feature or asset pack, maybe an installation as well. It's not the end of the world, but it's a bit trickier. Testing is a bit trickier as well. But just a little bit more work that you'll have to do, bear that in mind. We still need an app update to update the model, because it's part of the app like before. And as said, some apps don't support it. So again, this is suitable when there's only one model or very few. It can scale a little to a few models, but when we only want the feature from some users. For example, we have a camera feature that allows you to take photos and videos and edit them. It tracks you, it tracks the background, tracks your face, tracks your hands, and does transformation to them and puts things over them. And then you can either record the videos or the photos and again send them, save them for later, do whatever you want with them. For example, that is me as a comic book hero, very flattering, as an even more flattering potato, and then my hand as a sports fan that moves it and duplicates it all over the screen. So all of the filters that do this are relatively big, and not everyone wants this. So believe it or not, most people want a keyboard to type, and some of them want to do this kind of videos. So we download this feature on demand when users try to use the feature for the first time. And again, when that happens, users see a spinner for a little bit. They understand it will take a little, and afterwards, when the feature is installed, they can use it normally. Another example where we use this is with a feature that we call search intent. And this tries to detect whether the user is interested in a product. And when that's the case, we show a button to let them do a Bing search for that product. This is experimental now. It's only in the beta version of the keyboard and only for some English speakers. And therefore, we use a dynamic feature as well to only deliver this to those people who are testing this feature. These models in particular are quite big, and at the moment they are only for English, so it's the same set of models for everyone. It's just only for a few of these users. And finally, the other approach we follow when we want something to be downloaded only to some users, but we also have a lot of different models for different users, is to download them at runtime. So we host them in a server somewhere. It is our server. It is our models. We can have as many as we want. And when we need to use one of these, we do, again, a request to get the model, and the model is downloaded, and it becomes part of the app. This is not the same as before when we were running the AI in the cloud, because here we download the model, we get it from the cloud, but then it runs on device. So all the processing happens on the device. This, again, doesn't increase the download size of the app, which is great. It will increase the install size a little bit once the models are installed. We don't use space for users who can't use the feature, and now we can update the model separately from the app, because users can download a new version anytime from any version of the app. If we build a mechanism to do that, and if we are careful with backwards compatibility, always remember there may be someone with a really old version of the app downloading a very new model, and that should still work. Like with dynamic features, where the installation could fail, the model download could fail, and you need to handle that. Again, not the end of the world, just retry or wait until there's connectivity or something. You just need to do a little bit more work. The main problem here is that now it's our servers and our models, so we have to pay for the download costs. And if it's a lot of data and a lot of users, it can be expensive. So again, maybe you have to afford it. Like, we can't have a keyboard without a language that allows people to type, so we just have to afford it. But bear in mind, do your calculations, see how much it's going to cost, and make sure you can pay for that. This approach is therefore very suitable when the models are smaller, so the download costs are not that high. And when we have many different models, we use that for experimentation of various types, and especially for languages. And I already spoiled it, but let me tell you a bit more about languages. There are over 700 languages. When a user wants to use a new one, they can go to a very long list, like you see there on the left. They can search for the language they want, click on it, it will be downloaded, and then you can use it to type. You may think we can have dynamic features for that, but Google don't recommend you to use more than 50 dynamic features, and we have over 700 languages, so it's probably not a good idea. It's also probably not fun to manage 700 dynamic features, so they're in a server. These language packs are between 2 and 20 megabytes, depending on how complex the language is. So having them on device for all users is not really an option. It will be hundreds of megabytes on everyone's phone when people are only going to use a few of them. We use this approach for everything related to typing, and you might think, what else is related to typing? There can be a few things. For example, emoji. We have two types of emoji prediction. One is emoji prediction as you type, which you have to enable in the settings if you want to try it. So in the example here, I typed "I love," and one of the candidates became that emoji with hearts in response to what I typed. And we also have a predictive panel for longer things that gives you more emoji. For example, there I said, "I love flowers," and I got all of those emojis with hearts and with flowers responding to the love and the flowers. We also have a handwriting feature for some languages. So English is a relatively simple language when compared to others. There are languages with many, many characters where finding the right character is a challenge. You can't have them on screen. And drawing the character you want is a popular method for that. So you can see there, for example, I drew the character that represents mountain in Mandarin, and you can see how it became the first one in the list. So it's easy to find once you've drawn it. So summarizing all of the on-device approaches and our rules of thumb, if you can use Gemini Nano, it's probably the best option and the least work for you, but its availability is very limited at the moment, and I haven't tried it, so explore it. If you have your own model and you have to do something with it, which is where it gets interesting, the easiest option is to put it directly into the main app. But that will be better if it's the same model for all users. If it's the same model or a similar one or a few models, but very few, but the same for all users, you might prefer to use a dynamic feature. And finally, if you have many, many different models and you have to distribute different ones or different combinations to different users, it might be better to use a server and download them from there. That's what I wanted to share with you today. So I just leave here a few links, and I'll take some questions. But before, I want to thank all of the people who have been part of these discussions and have been doing this work and whose work I'm essentially presenting here. Also, thank them for their support in creating this presentation, and special thanks to those who will watch the video even though they've already listened to this a few times. And thank as well the organization for inviting me here today. And finally, thank you all for attending this talk.